This is First Coast Math Clinic with Lesson 9, Solving Equations with Variables on Both Sides, from Unit 2, Equations and Expressions, with a pre-algebra and algebra focus. So the goal in this video is to solve and check equations with variables on both sides. So we're going to look at equations like this: 3x plus 9 equals 5x minus 7. And let's go through a series of steps to solve these equations. So our first step is we want to combine like terms across the equal sign using inverse operations. And like terms, we know, are terms with the same variable raised to the same power. I have another video on like terms. The link for that should be coming up right now if you want to review like terms. But our like terms from this equation should be 3x and 5x and 9 and at minus 7. We want to keep our signs with our like terms. And we want to combine them using inverse operations. So inverse operations are operations that undo each other. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. All right. So let's start with maybe the 3x and the 5x. So I want to combine those two terms. So I'm going to move 3x to the right. And if I read this left to right, 3x is positive. So I need to undo adding 3x. I'm going to undo adding 3x by subtracting it from both sides. So minus 3x and minus 3x. So 3x minus 3x is 0, cancels out, so we can get rid of that. I'm going to bring down the 9 equals 5x minus 3x is 2x minus 7. Now we can combine the 9 and the 7. Well, my goal is to get that x by itself, right? So instead of moving the 9 to the right, I want to move the 7 to the left. So the way we're going to do that using our inverse operations, what sign is on that 7? 7 is a minus sign or a negative sign on the 7. 7 is being subtracted, so let's undo subtracting 7 and add 7 to both sides. All right, because if I add 7 now, negative 7 plus 7 cancels out, it's 0. So now I get 2x equals 16. My next step, I want to isolate the variable using inverse operations. So I want to get that variable by itself. I have 2 times x. What's the inverse operation of multiplication? It's division, so I'm going to divide by 2, divide by 2. 2 divided by 2 is 1 and 1. Well, multiplying and dividing by 1 doesn't really change much, so I could just write x equals, and then 16 divided by 2 is 8. And our third step is going to be check. So to check our answer, we're going to rewrite our equation. So our original equation, 3x plus 9 equals 5x minus 7. So we're going to take the 8, substitute in for x. So 3 times 8 plus 9 equals 5 times 8 minus 7. 3 times 8 is 24 plus 9. 5 times 8 is 40 minus 7. 24 plus 9 is 33. 40 minus 7 is 33, and we know our answer checks because the left side and the right side of our check are equal. So that's how we check our answer. And once the left side and the right side are equal to each other, we know our answer here, x equals 8, is the correct answer. All right, let's get into a couple more examples. We're going to go through 3 more examples in this video. All right, example 2, we've got 7x plus 1 equals 12x minus 14. So we want to combine our like terms across the equal sign. So let's start with the 7x and 12x. I'm going to move the 7x to the left. So 7x is positive. We read this from left to right. So I'm going to subtract 7x and subtract 7x from both sides. 7x cancels out. So we'll get 1 equals 5x minus 14. Now I need to combine the 1 and the 14. Those are my like terms across the equal sign. So I'm going to add the 14. I want to move 14 to the left because my goal is to get that x by itself, right? So I want to move everything away from that x now. So negative 14 plus positive 14 is 0, so I can get rid of that. And I'll get 15 equals 5x. Now I want to isolate the variable using inverse operations. So let's divide by 5, divide by 5. 5 divided by 5 is 1 and 1. Multiplying and dividing by 1 doesn't change anything, so I could just keep the x equals, and then 5 divided by 5 is going to give me 3. So x equals 3. And our last step is we could check our answer. So let's take our original equation, 7x plus 1 equals 12x minus 14. So let's take that 3, put it in for x, put it in for x. So 7 times 3 plus 1 equals 12 times 3 minus 14. So let's simplify this. 7 times 3 is 21 plus 1, and we get 22. 12 times 3 is 36 minus 14. 36 minus 14 is 22. So the left side and the right side are equal to each other, so our answer checks, and our answer is x equals 3. All right, let's go on to number 3. All right, example number 3, we've got negative 3x minus 4 equals negative 1x minus 2. So we've got a bunch of minus signs here that we're going to work with. We want to combine our like terms across the equal sign. So I'm going to start with, let's start with the constant. So we'll start with the negative 4 and the negative 2. We have a choice here. Let's bring the negative 2 to the left, right? So you have to use our inverse operation. So we're subtracting 2, so to undo subtracting 2, I'm going to add 2 and add 2 to both sides. Negative 2 plus 2 cancels out. So I'll get negative 3x and then negative 4 plus 2, where I want the difference when I add two numbers of opposite signs, and I want to keep the sign of the number with the larger absolute value, so that's going to be negative. So I'll get negative 2 or minus 2. Then I'll bring down the negative 1x. Now I want to move the negative 3x to the right because my goal is to get the x's by themselves. So I'm subtracting the 3x, so let's undo subtracting 3x and add 3x. And add 3x to both sides. So negative 3x plus 3x cancel out. So I'm going to get negative 2 equals, then I've got negative 1 plus 3. So again, we want the difference, and we want to take the sign of the number with the larger absolute value. So that's going to be this positive 3. So we're going to get positive 2x. Last step, we want to isolate our variable using inverse operation, or our second step. Let's divide by 2. Divide by 2. 2 divided by 2 is 1. We don't really need to write the 1 in. It's not going to change our answer, multiplying and dividing by 1. Negative 2 divided by 2 is going to give us negative 1. So our answer here is x is negative 1. And our last step, let's check. So let's take our original equation for our check. Negative 3x minus 4 equals negative 1x minus 2. So I'm going to take that negative 1, put it in for x, put it in for x, and I get negative 3 times negative 1 minus 4 equals negative 1 times negative 1 minus 2. Negative 3 times negative 1. So when we multiply two numbers that are the same sign, we're going to get a positive. So I'll get positive 3 minus 4. Negative 1 times negative 1 is going to give us positive 1 minus 2. So I'll do the work up here. So I get 3 minus 4 equals 1 minus 2. 3 minus 4 is negative 1. 1 minus 2 is negative 1. So we get the same value on the left and the right. So our answer is going to check. So our answer should be negative 1. Okay. All right, let's move on to example number 4. All right, so for our last problem, number 4, we've got 2x minus 4 equals 3x plus 8. So we want to start by combining our like terms across the equal sign by using inverse operations. So our like terms are going to be, let's do the 2x and the 3x. So I'm going to move the smaller term to the bigger term. So I'm going to move the 2x to the 3x. Reading this left to right, the 2x is positive. So I want to undo adding 2x and subtract 2x and subtract 2x from both sides. 2x minus 2x cancels out. I'm going to bring down keeping the sign with the 4, so this is minus 4 equals 3x minus 2x is 1x plus 8. Now our remaining like terms are going to be the negative 4 and the plus 8. Remember, I want to get that x by itself. So let's undo adding 8. So I'm going to subtract 8 and subtract 8 from both sides. 8 minus 8 is 0, cancels out, so I can get rid of those. I'm going to bring down the 1x. Now I've got negative 4 minus 8. So if I do that over here, negative 4 minus 8. I have another video on subtracting integers, which should be coming up now if you want to review that. Use our subtraction rule, negative 4 plus negative 8. We're going to add two numbers of the same sign. When we add two numbers of the same sign, we keep the sign, add the numbers. So we're going to get negative 12. So our answer here is going to be negative 12. All right, and we don't really need that 1 there. Multiplying by 1 doesn't change anything. So we're going to get x equals negative 12. And now our check. Let's take our original equation, 2x minus 4 equals 3x plus 8, and let's substitute that negative 12 back in for x. So we're going to have 2 times negative 12 minus 4 equals 3 times negative 12 plus 8. 2 times negative 12, multiply two numbers that are opposite signs. The answer is going to be negative, so negative 24 minus 4, and then negative 36 plus 8. Negative 24 minus 4, again, we can rewrite this as negative 24 plus negative 4, and we're going to get negative 28. And then negative 36 plus 8, we're adding two numbers of opposite signs. So we're going to subtract the two numbers, so we're going to get 28. And we're going to take the sign of the number with the larger absolute value, which is this negative 36. So we're going to get negative 28. And we get negative 28 equals negative 28. So our answer checks. Okay. So this was a video for lesson 9, equations with variables on both sides. If you like this video, leave a like, comment, and subscribe. Hope these videos are helping you guys. Again, if you like this, leave a like, comment, and subscribe. First Coast Math Clinic.